All right, we're going to go over the solutions to the warm-up real quickly. You can also look at these on the calendar tonight. So hopefully you did okay with these radical simplifications. When you see, and this is going to occur a lot in the upcoming weeks, is a radical divided by a radical, like a fraction over a fraction. So you can look at this two different ways. Notice the denominators are both root 3s. You can treat that as clearing a complex fraction. Multiply numerator and denominator by the root 3, which will cancel those out, just leaving you with 1/2. The other way to think about it is, remember, division just means multiply by the reciprocal. So you can think of that as 1 divided by root 3 times the reciprocal of the bottom, root 3 over 2, which still simplifies to 1/2. All right, subtracting radicals, remember there's that 1 in front of it, so essentially you're taking 2 root 3 minus 1 root 3, which is just root 3, or 1 root 3. And squaring a radical, this will occur a lot also. Remember that's 2 root 5 times itself, 2 root 5. 2 times 2 is 4. Root 5 times root 5 is root 25, or a whole number 5, which is how you get 20. 4 times 5 is 20. And remember, you are going to need to simplify these without a calculator. Those of you that used a calculator, be sure if you're checking it, you do put those parentheses in there, because if you plug in this expression, it is just squaring the 5 and you will get 10 as an answer. So you need to use parentheses if you're checking with your calculator. All right, let's look at how you did on yesterday's lesson. So this is the answer to A. 150 is going to be in the second quadrant. So remember the initial side, terminal side right here. Sorry, let me go to a pen. Which the reference angle will be 30 degrees. If that's 150, which means you are looking at this triangle. Opposite 30 degrees is your 1/2. Opposite the 60 is the root 3 over 2, but since we're in the second quadrant, the x is negative. And remember, x is your cosine, and that's how we get negative root 3 over 2. Okay. The next one, sine of negative 30. We didn't look at negative angles yesterday, but we will. That just means to go clockwise instead of counterclockwise. So we're going to be going this way, ending in the fourth quadrant. So initial side, terminal side, okay, 30 degrees, that's my reference angle. So opposite, so actually sine of negative 30, we want the y value. So opposite of 30 is going to be negative 1/2. Sine is always your y value. Okay. And this one, remember 270, recognizing your quadrantal angles. You don't draw a triangle for this. You envision where is that on your unit circle, right? Let's pretend that's a good circle, centered. There we go. And 270 is going to be right here, and just write the coordinate there, which is 0, -1. Cosine is your x, sine is your y, so that's why cosine of 270 degrees is 0. Check it on your calculator. All right, these, it says if an angle is in quadrant 2, is the sign positive or negative? Well, that would be positive. Again, envision your quadrants. Right? And sine is your y value. So y is positive up here, right? So that means sine is actually going to be positive in the first and second quadrants. Sine is going to be negative in the third and fourth. Okay. And the last, so we have number 4 also, sorry. Which quadrants have angles with a negative cosine value? Well, that would be 2 and 3. Again, that is where your x is negative. So that's where you're going to have negative x values. Okay. So again, when you're thinking sine and cosine, think of your x and y values. All right, I'll let you guys look at these online. This should be integrated to review. So using SOHCAHTOA, you should have used sine for this one. Make sure you know how to solve correctly. It becomes a division problem. And if you're solving for an angle, that one you're going to be using the inverse trig ratio. So that one is tan inverse of 13/11. Okay, hope that helped.